Math 265A, Cuesta College. I'm Joe Vasta, and we are going to cover Bug 2. And with Bug 2, we've already learned some things about bugs, and the bug is just traveling back and forth on the number line. So he's just going back and forth. He's not flying above the number line. He's not levitating above the number line on this thing. This diagram right here describes the times and the positions. So at time 1 the bug is there, and then by time 7 he's there, and then time 9 he's there at the origin, and then time 11 it looks like he's at 5. So that is this description, and we learned this in Bug 1. So I guess the question is, what is the bug's displacement? So this is a new word, displacement. What is the bug's displacement from 1 second to 7 seconds? So where is the bug at 1 second? He's right here. And at 7 seconds, he's right there. So he started off here at 1 second, and we'll put a pin there, and at 7 seconds he's there. So his displacement is how much he's traveled, or where he's displaced. He's displaced 1, 2, 3. So his displacement is 3 feet. Okay. Another way of figuring out the displacement, especially when you don't have this diagram, is using the position function. So remember that the position function was like f of t. So what I'm going to do is I'm going to go f of 7 and f of 1. So f of 7 is the time. It just says where is the bug at 7 seconds. He's at 2 on the number line. And f of 1 happens to be -1. So it just so happens that you can get displacement by going f of the end time minus, so there's the minus there, f of the beginning time. And look what happens. 2 minus a -1 is a +3. So this gives us the displacement every single time. Okay, so the bug was displaced 3 feet to the right. Sometimes the displacement can be negative, like if the beginning time the bug is here and the end time the bug is over there. Okay, so sometimes the bug can be, his displacement can be negative. What is the bug's average velocity from 1 second to 7 seconds? Well, how many seconds does this span? How many seconds is it between 1 second and 7 seconds? It's actually 6 seconds. So it's a 6-second interval. So to get average velocity, now when we think velocity, we think feet per second. Okay? So what we're going to do is we are going to take this displacement, which is 3 feet, and we're going to put it over how much time has gone by from 1 to 7 seconds, which is really 6 seconds. So the bug's average velocity from 1 to 7 seconds happens to be 1/2 foot per second. And that's the answer. So let's go ahead and put up some formulas that we can use. We can say the bug's average velocity is really the displacement from 1 to 7 over the time. Okay, the displacement was 3 and the time was 6 seconds. Maybe a cleaner formula would be the displacement was f of 7 minus f of 1 all over the time. We just said it was 6. We just said, oh, we know what it is. But really what we were doing was we were finding what the difference was. We were really going 7 minus 1. So when you're looking for displacement, you go f of end time minus f of beginning time. When you're looking for average velocity, you're doing the displacement f of end time minus f of beginning time over, and then we take the difference of the times. And so, I'll write this out again. F of 7 minus f of 1 is 2 minus negative 1. And on the bottom we have 6, which was 3 over 6 feet per second. So that is the bug's average velocity from 1 second to 7 seconds. And it doesn't mean he was necessarily going 1/2 feet per second the whole time. He could have gone like really quickly at the beginning and then slowed down until he got there. And the average velocity is sort of just the average of what he was doing. So he could have gone quick at the beginning and slower than 1/2 feet per second at the end. Now, what is the bug's total distance traveled from 1 second to 7 seconds? Now, this seems kind of silly because we've already computed the bug's displacement. So the bug's total distance traveled almost seems silly because it seems like it is the displacement. I mean, look at the total distance traveled. You traveled 1, 2, 3. So this is 3 feet. This is not going to be as silly when we do other problems where we're looking at the displacement from time 1 to time 9, and then the total distance traveled will not always be the displacement. Let's go ahead and do problem number 2, which is actually going to have the same bug diagram, but our time intervals are going to be different. Okay, what is the bug's displacement from 7 seconds to 9 seconds? Well, 7 seconds, he's right here. Or he's really right here, you know, down at 2. And 9 seconds is right here. So it looks like he's at 0. So you're going from so you're really going from here to here. So at the beginning the bug is right there, meaning beginning at 7 seconds the bug is there, and at 9 seconds the bug is there. So how much has he been displaced? He's actually been displaced in the negative direction, so his displacement is -2 feet. Now, let's go ahead and use the formula to see if that gets us what we want. The formula says we're going to go f of the end time, so f of 9, minus f of the beginning time. So what is f of 9? F of 9 seconds is where? 0. And f of 7, it just says where is he at 7 seconds? He's at 2. And we go 0 minus 2, which gives you the -2 feet. Okay, so that is the bug's displacement. And I want you to just really get these words: displacement, average velocity, total distance traveled. Okay, so now the bug's average velocity. So I'll do this the quick way. The quick way means we already know that the displacement was -2 feet. And we know that to get the average velocity, we take the displacement and we divide by the time. Well, how much time is between 9 and 7? Well, 2 seconds. Now, -2 over 2 gives you -1 feet per second. And that's the quick way of doing it, especially if you've just found the displacement. So that's the average velocity. Now the other way that will always get you the right answer is you take the displacement, and I'll write it as f of 9 minus f of 7, and we're really doing the same thing. This is divided by the time, 9 minus 7. We really did 9 minus 7 in our heads to get that 2 at the bottom there. So f of 9, and I know, this is a pain because we already know what the answer is. So this is 0, and f of 7 happens to be 2. So 0 minus 2 over 9 minus 7. This is -2 over 2, which gives you the -1. Okay, so now it says, what is the bug's total distance traveled from 7 to 9 seconds? Well, let's think about it. His displacement is -2, but the total distance that he traveled, I mean, we could just try to trace it out. 1, 2. So it happens to be 2 feet. One thing about the total distance traveled, this will always be positive. So this is always positive. And it has the same units as the displacement. The displacement can be negative or positive. So this completes problem number 2. It's a little different from problem number 1 because the displacement was negative, and that actually forced the average velocity to be negative as well. Okay, so problem number 3 is where it really gets interesting. Everything's the same except the time interval got changed from 1 to 11. Okay, so at 1 second, where is the bug? He's right there. And at 11 seconds, the bug is, well, the bug kind of goes like this, zzz, and then 11 seconds, he's right here. So it looks like his displacement is going from here to there, which will be a positive number. In fact, we can count 1, 2, 3, 4, 5, 6. His displacement is 6 feet. As tempting as it is to say I will always do displacement that way, it's not going to work out nicely when you do not have an arrow diagram, when you have functions given different ways. You can't always just follow the arrow diagram because you won't have it. So 6 feet is the displacement. So that's why I'm always like going ahead and showing you the formula. The formula says, this is the position function, f is f of the end time minus f of the beginning time. And we kind of did that in our head. We knew we went to -1 and 5, but watch this. F of 11. So at 11 seconds, where is the bug? He's at 5. Minus f of 1. So at time 1, the bug is sitting where? He's sitting at -1 on the number line. So look at this. 5 minus a -1 gives you 6, which is exactly what we have here. You have to put your units, but I mean, I've already have the answer there. So that is the bug's displacement from 1 second to 11 seconds. What is the bug's average velocity? Well, here's the funny part about this. The bug has a positive velocity there, and then turns around and has a negative velocity, and then has a positive velocity. So the average velocity is just going to be the average. It's either going to be negative or positive. Since we probably didn't travel too much in the negative direction, it might average out to a positive velocity. Let's see. The quick way of doing this is taking the displacement and putting it over the time elapsed. So how much time is it between 1 and 11? Well, it would be 10 seconds. And so 6 divided by 10, or 6 over 10, if you reduce that fraction, it gives you 3/5 feet per second. And so there is the bug's average velocity. Now for all you perfectionists out there, you probably noticed I wasn't color coding it. Not that we have to do this, but you know, we want to try to please all the people with this here. There's the average velocity. Now, the formula for the average velocity, it is displacement over time, which is a really good thing to remember. But if you really wanted to go from scratch here, you would say f of 11 minus f of 1 all over 11 minus 1. And this gives you average velocity. So f of 11, so we already did that calculation. That's why we just put the 6 feet there, but I'll do this again. And then on the bottom we have 10, and this is 6 over 10, which gives us our answer. So the average velocity is 3/5 feet per second. It is a positive average velocity, but know that the average velocity doesn't mean you're always going that velocity, and as we can see, the bug is going in a negative velocity between time 7 and time 9. So this is just an average velocity, not to be confused with something we'll be talking about later on, which is the instantaneous velocity. And that's the one you might feel more comfortable with. You're driving the car and you're going 65 right at that instant. So this is not that. This is the average velocity. Okay, the bug's total distance traveled. Okay, so this one, you know, some of you were thinking from the other problem it's always going to be the absolute value of the displacement, but that's not going to be the case here. This one, the only way we can do total distance traveled is to actually count it out as we travel here. So look, 1, I'm seeing the total distance from here to here, you know, and we are going to count the turnaround part. So 1, 2, 3, okay, we're right there. 4, 5, now we're back up there. 6, 7, 8, 9, 10. So the total distance traveled is always going to be positive, and it is 10 feet for this time interval. And so some of you are probably thinking to yourself, that's not very mathy. There's not really a good formula because we're just counting with our fingers. How unscientific. At this point, that's the best that we can do. But there is more of a mathy way of doing this, but we have to know something about derivatives and calculus to find the turnaround times. And then we could actually put a formula here, but right now, this is the way we should do it. So this completes problem number 3. We are now going to do problem number 4, our last problem for bug 2. And what I would ask you to do, let's put problem number 4 up. I would ask you to pause the video and see if you can do this on your own. That's going to help you the most. So we'll often ask you to pause the video when we've already done some similar problems. And some of you are not going to pause the video. You'll just say, let's just see what he does. But really, number 4 probably doesn't have to be done. But I'm doing it anyway, just so you can see some extra problems. So I'll give you time to do it. Well, I don't have to give you any time. Just pause it, and then when you're done, turn it back on and see if you get the answers that I'm going to get. I'll do these problems, the first 2, the quick way, and then the formula way, and then this one I'm just going to do by counting. So the bug's displacement from 1 second to 9 seconds. So here's t equals 1 second, he's right there. And at 9 seconds, he's right there. So he's starting right there at -1 and stopping in this time interval at 0, or the origin on the number line. So his displacement just looks like he went 1 to the right, or we would just say 1 foot. That's all the displacement is. Now, the formula way would say f of n time, so f of 9 minus f of beginning time, f of 1. So f of 9, and you would just do the same, f of 9 is, oh, he's at 0. And then f of 1 time 1, he's at -1. And so this gives me 0 minus a -1, which is 1, which gives me the answer that I got. The bug's average velocity. So displacement, and I haven't been writing this, but I will this time, over time. The displacement is 1 foot over the time. Well, the time between 1 and 9 happens to be 8 seconds. And so we're going to write this out as 1/8 foot per second. The formula way of doing this, and we will be looking at the formulas as we do the calculus, is you put the displacement, f of 9 minus f of 1, all over 9 minus 1. And essentially, if you're getting a little irritated that I'm doing it both ways, I just want to show you this formula, so if it does come up and we absolutely have to use it, you'll say, oh yeah, that was that formula. So this is 0 minus a -1, and on the bottom we have 8, which gives me 1/8. So the travel went like this. We went like this. From 1 second to 9 seconds, we went like this. And then came back to 0. And it seems like our average velocity happens to be positive, even though sometimes we were going with a negative velocity. The total distance traveled. Well, the total distance traveled means I'm going to have to count this as I go from time equals 1 to time equals 9. So here I go. I have to count on the number line. 1, 2, 3. Now I turn around. 4, 5. So the total distance traveled was 5 feet. Even though the displacement was only 1 foot, the displacement's just a snapshot. What happened at beginning time, what happened at end time. Oh, he's 1 to the right. Total distance traveled is not just a snapshot between the beginning time and the end time, but it's actually tracking how far the bug traveled on the number line during the time interval. So this completes problem number 4 of bug 2. Keep up with your homework. The bug handouts are located on the main page of the website. And our next lecture will be bug 3.